You use electricity every second of every day. Right now, it's powering the device you're watching this on. It's lighting your room. It's running the servers that delivered this video to your screen. So explain it to me. What is electricity? What actually happens when you flip a switch? Most people say energy or electrons moving. Both wrong. They just rename the mystery without explaining anything. And here's the proof that you don't understand it. A proof so simple it sounds like a joke. You have never touched anything in your entire life. Not your phone. Not your coffee mug. Not another person's hand. There is a gap nanometers wide between your skin and everything you've ever touched. The electromagnetic force, the same force behind what we call electricity, won't let your atoms get close enough to make contact. That force is 10 to the 42nd power times stronger than gravity. 1 followed by 42 zeros. It's so incomprehensibly powerful that it creates the illusion of solid matter. The illusion of contact. The illusion that your hand is resting on a table right now. Your teacher explained static electricity in middle school and moved on. They should have stopped the class. Because what you were looking at was one of the most powerful forces in the universe, the force that holds every atom in your body together, fires every neuron in your brain, and powers every piece of technology on Earth. And the way we teach it completely hides that weirdness. We make it sound normal, predictable, safe. It's none of those things. Let me show you why. And I want you to do this with me. Here's an experiment. Simple one. Take a piece of plastic wrap. Rip off a strip. Now, rub it between your hands really fast, like you're trying to warm them up. 10 seconds. That's all you need. Now hold it near the back of your hand. Don't touch. Just hold it close. Feel that? The hairs on your arm are moving. Standing up. Reaching toward the plastic. You can actually feel the plastic pulling on you from a distance. Stop and think about that for a second. You rubbed plastic. That's it. No batteries. No wires. No power source. Just friction. And now that plastic can reach across empty air and tug on your body. How? In your normal experience of the world, things only push or pull when they're touching. You push a chair, you touch it. You lift a book, you touch it. Forces require contact. Except here's a piece of plastic. Not touching you. Pulling on your arm hairs through empty space. Most people shrug. Static electricity. We learned about that in middle school. It's not important. Not important? You're looking at the force that holds every atom in your body together. The force that makes chemistry possible. The force that allows your neurons to fire, your muscles to contract, your eyes to see. You're looking at one of the 4 fundamental forces of the universe, demonstrating its ability to act across distance. And you think it's a parlor trick. This is the problem. We've become so familiar with electricity that we've forgotten how absolutely insane it is. Let me show you just how insane. When you rub that plastic wrap, here's what actually happened at the atomic level. You scraped electrons off your hands and piled them onto the plastic. Just a few trillion extra electrons. Sounds like a lot? In the world of atoms, it's essentially nothing. Maybe 1 electron in every trillion shifted. But those excess electrons despise each other. They push away from each other with a force so large, you literally cannot comprehend it. Let me try anyway. Take 2 electrons. Place them 1 centimeter apart. The electromagnetic force between them is about 10 to the 42nd power times stronger than the gravitational force between them. 10 to the 42. That's a 1 followed by 42 zeros. To put that in perspective, the number of grains of sand on every beach on Earth is about 10 to the 19. The number of stars in the observable universe is about 10 to the 22. The electromagnetic force compared to gravity is a number that makes those numbers look like rounding errors. The electromagnetic force is so incomprehensibly stronger than gravity that gravity might as well not exist. For electron, gravity is irrelevant, meaningless. Electromagnetic forces are everything. So here's the obvious question. If these forces are that monstrously strong, why isn't everything exploding? Why doesn't matter just tear itself apart? The answer is almost magical. Cancellation. Think about what an atom actually is. At the center, protons with positive charge. Around them, electrons with negative charge. Positive and negative. Like repels like. Opposites attract. And the forces are exactly equal in magnitude. Imagine 2 armies, each with a trillion soldiers, perfectly balanced on a battlefield. Every push is matched by an equal pull. Every repulsion is canceled by an equal attraction. The war is perfectly deadlocked. Remove 1 soldier, just 1, and you feel the imbalance across the entire field. That's what happened when you rubbed that plastic wrap. You moved maybe 1 electron in every trillion. Essentially nothing. But when the underlying forces are that enormous 10 to the 42, even the smallest excess creates a noticeable effect. That's why your arm hairs stood up. And the precision of this balance is staggering. The electric charge of an electron is exactly equal and opposite to the charge of a proton. Verified to 1 part in 10 to the 21st power. That's 1 followed by 21 zeros of precision. The electron and the proton are completely different particles. Different masses. Different sizes. Different origins. Why are their charges perfectly matched? No one knows. But if they weren't, if there were even the tiniest mismatch, matter as we know it could not exist. Stars wouldn't form. Chemistry wouldn't happen. You wouldn't be here. Now, in normal matter, this cancellation is so precise that the net effect is 0. The monstrous forces are still there, still acting, every second, in every atom of your body, but they're balanced. Perfectly. So you don't feel them. But every once in a while, something disrupts that balance. Rub plastic. Move a few electrons. And suddenly, you feel the giant wake up. That's what electricity is. Not a gentle flow, not a safe, predictable current. It's the smallest ripple on the surface of the most powerful force in the known universe. But here's the part that should completely restructure your worldview. The part your teacher never told you. Pick up your phone. Right now. Feel its weight. Feel the glass against your fingertips. That solid, cool surface pressing back against your skin. Here's the thing. Your fingers aren't touching the glass. There's a gap nanometers wide between your skin and the screen. You're feeling electrons in your hand, pushing away from electrons in the phone with enormous force. Electromagnetic repulsion. The same force you felt with that plastic wrap, but now happening between every atom in your finger and every atom in that glass. That weight you feel? That's not contact. That's 10 to the 42. Think about what this means. The reason you can't push your hand through a table, the reason anything feels solid at all, is because the electromagnetic forces between atoms are so monstrously strong that the electron clouds refuse to overlap. Your hand gets close, nanometers close, but it never arrives. Not really. There's always a gap. The mug on your desk, the chair you're sitting in, the floor under your feet, your hand on another person's hand. Every one of those sensations, pressure, resistance, texture, warmth, is the electromagnetic force. Every push you've ever felt, every pull, every sensation of touch in your entire life has been the electromagnetic force saying no. You have never touched anything in your entire life. Not your phone, not your coffee mug, not another person. There has always been a gap. Contact is an illusion created by a force so powerful it fools every one of your senses into believing solid objects exist. They told you about forces in physics class. They drew diagrams with arrows. They taught you normal forces, friction, tension. They never told you that all of those are the electromagnetic force wearing different masks. They never told you contact is an illusion. So far, electricity isn't simple. The electromagnetic force is 10 to the 40, 2 times stronger than gravity. And you've never actually touched anything in your entire life. Now here's where it gets really interesting. Now let's talk about wires. Because what you think you know about how electricity travels through a wire, that's wrong too. The standard explanation goes like this. Electricity flows like water. Electrons enter the wire at one end, travel down its length, and emerge at the other end. Clean. Simple. Easy to picture. Completely wrong. They drew those diagrams in school. Little arrows showing electrons flowing from negative to positive, like water through a pipe. That's not what happens. Not even close. Here's what actually happens inside a copper wire. A copper wire is already packed with electrons. About 8. 5 times 10 to the 28 free electrons per cubic meter. Billions of trillions of electrons, just sitting there, jostling around randomly, in every piece of copper you've ever seen. When you close a circuit, when you flip that switch, you don't inject new electrons into the wire. You apply a voltage, a push. And here's what's strange. The electrons themselves barely move. In a typical household wire carrying 1 amp of current, electrons drift at about 0. 23 millimeters per second. Let me say that again. 0.23 millimeters per second. At that speed, a single electron would need over an hour to crawl 1 meter of wire. But when you flip a switch, the light turns on instantly. How? Because it's not the electrons that travel fast. It's the push. Think of it this way. Imagine a long line of people standing shoulder to shoulder in a hallway. Thousands of them, packed tight, stretching from one end to the other. Now push the person at one end. Just a nudge. The person at the other end feels it almost immediately. Not because the first person walked down the line. That would take forever. The push, the force, was transmitted from person to person through the crowd. Each person barely moved. But the signal reached the other end almost instantly. That's what happens in a wire. The electrons barely move. But the electromagnetic push propagates through the wire at close to the speed of light, nearly 300 million meters per second. The useful thing about electricity isn't that electrons are fast. They're absurdly slow. The useful thing is that the electromagnetic force, the same force that pulled your plastic wrap, the same force that creates the illusion of touch, can transmit a push almost instantaneously across any distance. That's what you're really doing when you flip a switch. You're not sending electrons. You're sending a push. But where does the push come from? Let's trace it back. You flip a light switch. Electricity flows, or at least, that's what most people think. But let's actually follow the chain. The lamp connects to an outlet. The outlet connects to wires running through your walls. Those wires connect to a power line outside. That power line stretches sometimes hundreds of miles back to a power plant. And what's inside that power plant? Not a giant battery. Not some mysterious electron factory. A turbine. Spinning. Here's what's actually happening. A massive magnet rotates inside coils of copper wire. That's it. A magnet and a wire. And that spinning motion, that mechanical energy, creates the electromagnetic push that travels all the way to your lamp. So electricity isn't one thing, and magnetism another. They're not separate forces that happen to coexist. They are the same force, two faces of one phenomenon. The electromagnetic force. Think about that for a second. Every motor you've ever used? Electromagnetism. Every generator? Electromagnetism. Every transformer that steps voltage up or down so your phone charger doesn't explode? Same force. Same principle. One force runs your refrigerator, charges your phone, lights up cities, and powers MRI machines that can see inside your body without cutting you open. And here's what makes this extraordinary. This unification, this discovery that electricity and magnetism are one, didn't come from a university lab. It didn't come from a professor with a wall of degrees. It came from a bookbinder. A bookbinder who never went to university. Who taught himself science from the books he was paid to bind. His name was Michael Faraday. And what he did on one August afternoon in 1831 changed everything. London, 1791. Michael Faraday is born into a family that can barely afford bread. His father is a blacksmith, not the romantic kind from movies, but a man whose hands shake from years of hammering iron in the cold. The family moves between cramped rooms. Some weeks, young Michael's entire food ration is a single loaf of bread, one loaf meant to last 7 days. He doesn't go to school. Not really. His formal education ends before he turns 13. At 14, he becomes an apprentice to a bookbinder named George Ribot on Blandford Street. His job: cut paper, stitch pages, press leather covers. Day after day. For 7 years. But here's what the books didn't expect. The boy started reading them. One book in particular changes everything. Conversations on Chemistry by Jane Marcet, a book written to make science accessible to people who'd never set foot in a lecture hall. Faraday doesn't just read it. He starts doing the experiments. In the back of the bookshop, with scraps and leftover materials. Picture this: a teenage bookbinder, hands stained with ink and glue, building crude electrical devices from instructions in a book he was supposed to be binding for someone else. He writes to every scientist he can think of. Most ignore him, but one doesn't. Sir Humphrey Davy, the most famous chemist in England, the man who discovered sodium and potassium, hires Faraday as his laboratory assistant at the Royal Institution. The year is 1813. Faraday is 21. Fast forward 18 years of relentless experimentation. August 1831. Faraday wraps a coil of copper wire around an iron ring. He connects one side to a galvanometer, a device that detects electric current. Then he takes a simple bar magnet and pushes it through the coil. The needle twitches. Pull the magnet out, the needle twitches again. Opposite direction. No battery. No chemical reaction. Just a magnet, a wire, and motion. Let that sink in. A moving magnetic field created an electric current out of nothing but motion itself. This is electromagnetic induction. And you can replicate this exact experiment today, 195 years later, with equipment that costs less than a cup of coffee. That's not a metaphor. That's not a simplified version for YouTube. That is literally what happens inside every power plant on Earth right now. Faraday's coil and magnet scaled up to the size of a building. A blacksmith's son. No formal education. Taught himself from borrowed books in a bindery. And he gave us the principle that powers the modern world. But the story doesn't end there. 34 years later, in 1865, a Scottish mathematician named James Clerk Maxwell takes Faraday's experimental discoveries and translates them into 4 elegant equations. Just 4. They describe every electromagnetic phenomenon in the universe: light, radio waves, X-rays, the screen you're watching right now. Einstein kept a photograph of Maxwell on his study wall. When asked why, he said Maxwell's work was the most profound and the most fruitful that physics has experienced since the time of Newton. A blacksmith's son who bound books for a living, and a mathematician who saw patterns where others saw chaos. Together, they gave us the modern world. So, if you've made it this far, you now understand something most people never will. Electricity isn't what you thought. It's not electrons racing through wires. It's a field, a force, discovered by a bookbinder and perfected by a mathematician. And we're only getting started. Let's go back to that light switch. Because now you have everything you need to understand what really happens when you flip it. And I mean everything. Not the simplified version. Not the textbook diagram. The real, full, unbroken chain from power plant to your brain. Ready? You close the circuit. Electrons throughout the wire begin to drift slowly. Remember, 0. 23 millimeters per second. Barely moving. But the push, the electromagnetic push, races through the wire at nearly the speed of light. Now trace it backwards. Miles away, inside a power plant, a turbine is spinning. Water falling, or gas burning, or steam expanding turns a massive shaft. Attached to that shaft, magnets, rotating inside coils of copper wire. Faraday's principle. 1831. A magnet moving near copper. The same experiment a bookbinder did with his hands scaled up to the size of a building. That changing magnetic field pushes electrons. The push, not the electrons, propagates through hundreds of miles of wire. At nearly the speed of light. All the way to your house. The push reaches a thin filament inside your light bulb. Electrons squeeze through that narrow wire. They resist. That resistance generates heat. The filament gets so hot it glows white. And now electromagnetic waves radiate outward from that filament. Some of those waves, a narrow band we call visible light, travel across your room and hit your eyes. Inside your retina, those oscillating electromagnetic fields cause electrons to move. Those moving electrons trigger chemical reactions. Those reactions send electrical signals through your neurons. Your brain processes those signals, and you see light. Turbine, wire, filament, electromagnetic wave, retina, neuron, brain, every single step. Electromagnetic. One force. One continuous, unbroken chain from a waterfall miles away to a thought inside your skull. Faraday's 1831 discovery. Running at the speed of light, ending in your consciousness. Look at the nearest light right now. Any light. Trace the chain backwards. That glow started as motion, a turbine spinning miles from where you're sitting. That mechanical energy became electromagnetic fields. Those fields traveled at nearly the speed of light through wires. And now they're entering your eyes. Right now, you're not just looking at a light bulb. You're watching stored energy, delivered by the electromagnetic force, converted back into the very electromagnetic waves your eyes evolved to detect. That's not a metaphor. That's literally what's happening. Right now. That chain turbine to retina, that's not just a thought experiment. It's happening right now. In the device you're holding. In the lights around you. In everything. And I mean everything. That wireless charger on your desk? Remember the transformer 2 coils of copper. No physical connection. Current appears in the second coil through empty space. That's your wireless charger. Put your phone on the pad, and electromagnetic fields transfer energy across a gap of air. No wires. No contact. Same physics Faraday discovered in 1831. Now sitting on your nightstand. Those magnetic fields we talked about? In hospitals, doctors use them to see inside your body without cutting you open. MRI, magnetic resonance imaging. The electromagnetic force, manipulated with extraordinary precision, mapping the water molecules in your tissues. No radiation, no incision. Just fields and frequencies. Faraday's principle, saving lives. That motor in an electric car, same principle. Reversed. Push electricity through copper in a magnetic field, the wire moves. Scale it up, and you get hundreds of horsepower from the same interaction a bookbinder demonstrated with a coil and a magnet nearly 2 centuries ago. And the screen you're watching this on right now, capacitive touchscreen. Here's how it works. Your finger changes the electromagnetic field at the point where you press. The screen detects that change. That's how it knows where you're touching. Except, remember, you're not touching. You never touch the screen. There's always a gap. The electromagnetic force is doing everything. Sensing your finger. Lighting up the pixels. Transmitting the signal. All of it. Touch the table in front of you. Press hard. Feel that resistance? That's 10 to the 42. That's the electromagnetic force saying no. Same force that moved the plastic wrap in your first experiment. Same force running your phone. Same force Faraday found with a magnet and a coil. Everywhere. Always. One force. From Faraday's workshop to your wireless charger. From Maxwell's equations to your MRI scan. From a bookbinder's experiment to the electric car in your neighbor's driveway. One force. discovered nearly 2 centuries ago. Running everything you see, touch, and use. But here's what we still don't know. Maxwell's equations predict everything. Every electromagnetic phenomenon you've ever seen, heard, or measured predicted with absolute precision. Published in 1865, and not once has an experiment contradicted them. So you'd think we're done, right? We figured it out. Case closed. Here's the honest truth. And I mean actually honest, not honest the way most science videos use that word, right before they give you a neat, satisfying answer. We do not understand why this force exists. We know how it works. We can measure it. We can predict it. We can manipulate it to build phones and MRI machines and power grids that span continents. But why the electromagnetic force has the specific strength it has, why it behaves exactly the way it does, nobody knows. Remember that number 10 to the 42nd power? The electromagnetic force is that much stronger than gravity. But why that number? Why not 10 to the 40th? Why not 10 to the 50th? This isn't a trivial question. If that ratio were even slightly different, slightly atoms wouldn't form. Chemistry wouldn't exist. Stars wouldn't shine. You wouldn't be here watching this video. And nobody, no physicist on Earth, can tell you why it's this exact number. And here's another one. The electron's charge is exactly equal and opposite to the proton's charge. Not approximately. Exactly. Verified to 1 part in 10 to the 21st. But the electron and proton are completely different particles. Different masses. Different sizes. Different internal structures. So why? Why are their charges perfectly matched? No one knows. Quantum electrodynamics, the theory Richard Feynman helped create, predicts electromagnetic phenomena accurate to 12 decimal places. 12. It's the most precise theory in the history of science. And it still doesn't answer why. That's not a failure of science. That's science being honest about where it currently stands. The questions are still open. The mystery is still alive. I could have skipped this part. Most videos do. They wrap everything in a neat bow and make you feel like humanity's got it all figured out. But you deserve the honest picture. The beautiful, incomplete, still unfolding, honest picture. So what is electricity? Really? After everything we've seen, the force, the illusion, the book binner, the equations, the mystery. What's the real answer? Electricity isn't a thing. Let that land for a second. After 30 minutes of talking about it, here's the answer. Electricity is not a substance. Not a fluid. Not a mysterious energy that flows through wires like water through pipes. Electricity is what we call it when we manipulate the electromagnetic force to do useful work. That's it. That's the definition that actually holds up under scrutiny. A bookbinder with no formal education saw it first. Michael Faraday, a blacksmith's son who taught himself science from the books he was paid to bind, moved a magnet through a coil of copper wire in 1831 and watched a needle twitch. That was the moment. A mathematician saw it second. James Clerk Maxwell took Faraday's experiments and compressed them into 4 equations that describe every electromagnetic phenomenon in the universe. 4 equations. 1 page. Everything. And Richard Feynman? He spent a lifetime wondering why it works. Built the most precise theory in human history, accurate to 12 decimal places. And still couldn't answer the deepest question. A book binner. A mathematician. a Nobel laureate, and the mystery outlived all three of them. Think about what we've discovered today. The world seems mechanical. Solid objects pushing against each other through direct contact. You wake up every morning in a world that feels solid, predictable, touchable. But that world is an illusion. The real world is made of fields and forces acting at a distance. Particles pushing and pulling on each other through empty space. The plastic wrap reaching across air to tug on your arm. Your fingers never touching the phone screen. A turbine converting motion to electromagnetic waves that travel at the speed of light and end in your retina. Action at a distance isn't the exception. It's the rule. It's all there is. Next time you flip a light switch, actually, don't wait. Do it right now, if there's one nearby. Flip the nearest switch. You're not just turning on a light. You're commanding a fundamental force of the universe. The same force Faraday found with a magnet and a coil. The same force Maxwell captured in 4 equations. The same force holding every atom in your body together right now. You're converting motion to electromagnetic fields and back to motion across entire cities. In milliseconds. On demand. Every single day. Tell someone tonight. Just one person. Tell them you've never touched anything in your entire life. Watch their face. Then explain why. Walk them through the electromagnetic force. The cancellation. The nanometer gap between their fingers and everything they think they're touching. That's the beauty of real understanding. Once you see it, you can't unsee it. And you can give that gift to someone else. That's the real story of electricity. Not a utility. Not a convenience. Not a line on your monthly bill. A window into the fundamental nature of reality. And proof that a curious mind, even a bookbinder's, can pry that window open. Not comfort. Not familiarity. Truth. But here's something most people never think about. Every time you light a match, every time you see a flame, you're watching the electromagnetic force rearrange atoms in real time. Breaking bonds. Forming new ones. Releasing energy that you feel as heat. Fire isn't destruction. It's transformation. And the real question isn't what fire is. It's why it burns at all. Next time, we let Feynman answer that question. And his answer will destroy everything you think you know about fire.